Okay, so since some of you guys are gone this tomorrow, we're going to talk about some things just so you are not left behind. So the first thing we're going to talk about is we're going over page 304 in your book, which is lesson 4, and it's graphing simultaneous equations. So a couple things, if you read through your book, it'll give you good examples of what this looks like. But essentially, the point of this is to learn that when we have two equations, if we have y is equal to 15x, and then y is equal to 30 plus 10x, we can graph those. As we know for this first equation, oh my, that was not good. Let's see. So we know we have a line. And we know our slope is 15. So we're going to say each of these dots is 5. So we don't have a y-intercept. So our slope is going to look like this. We're going up 15 and over 1. And so we're going to have a graph that looks something like this. And we can draw this graph. It's very messy, but you get the point. Like we were doing with the slope-intercept form worksheets. So that is our first equation. This is our y equals 15x. And then we have our y equals 30 plus 10x. And we can put that into y equals mx plus b, which would be our 10x plus 30. Our slope is our 10. Our y-intercept is 30. So we can say if we're going by 30s, this is our 30 where we cross. And then we have our slope. So it's going to be like this. So if we continued these graphs, this is really messy, but this would go like this, and then again like this, and this one would go like this, like that. Ow! We're going to go like this, and then way up here, we're going to eventually cross. And this is a little messy and off, but normally on graph paper, you should be able to, if you graph it properly, you should be able to tell where this crosses. And this value is going to have an x value and a y value. And that is called your solution. So that's your solution of your simultaneous equations. And if you remember, these are your simultaneous equations. Okay, so essentially that's what we're looking at, is we can graph your lines, and wherever they intersect is your solution. And that is all that it is for lesson 4. Pretty straightforward. If you have questions, let me know. I'm happy to answer them. Okay, lesson 5, we start talking about inconsistent and equivalent equations. So there are 3 types of simultaneous equations. Our first type is one that are justified by our solutions. Okay, we can have one solution. We can have no solutions, or we can have infinite solutions. So, how we can tell this is on a graph, our one solution, it's going to cross. This is our graph, and this is a line, and this is a line. We have one point of intersection, and they will never cross again. That's going to be our one solution. If our lines are parallel, we're going to have no solutions because they never cross. And then if our lines are literally on top of each other like this, then we're going to have infinite amount of solutions because every single point is going to be a solution as they cross at every single point. So that is what that is. A couple things with, we went over this in class. If you have parallel lines, a quick reminder, if you have y equals 2x plus 5 and then 2x minus 3, these two equations are going to be parallel, and you can see that just from their slope. They have the same slope, which would essentially look like this, what we just did, because they're going to have the same slope, so they are never going to cross. Okay, so let me go through an example on this one. So, how do we add a page? Oh, this is fancy. This is how my instructional analysis teacher always teaches, and I think it works well. But this is going to be what we do. So we're going to do number 9 from set 2. It says this exercise is about the simultaneous equations. 2x plus 5y is equal to 10, and 2x plus 5y is equal to 0. So it says graph the two equations on one pair of axes. So what we can do from the start is we can change this into y equals mx plus b, because that will be easier to graph than plotting. What you could do is you could plot your x and y and plug your numbers in, but that's going to take a while. So I would suggest just turning these into your y equals mx plus b. So if we move 2x to the other side, we get, and divide both sides by 5, we are going to get y is equal to negative 2 over 5x plus 2. If you don't understand how I got that, I subtracted 2 from both sides, and then I divided both sides by 5. And I'll do it out for this one. So we get 5y, and if we subtract 2x from both sides, we're going to get negative 2x. We're going to divide both sides by 5, and we're going to get this equation as y equals negative 2/5 x. So what we just talked about up here is that if our slope is the same, our lines are going to be parallel. So just by looking at these equations, we can say that these lines are parallel, but we're going to double check it because that's what we're doing. In this class, we're double checking that our hypothesis and our shortcuts are actually working. So this bottom equation, we'll call that equation 1, and we'll call this equation 2. Our bottom equation of 1 crosses at 0, right? Because it doesn't have a a plus b. So we don't have a y-intercept, so it's 0. So we cross at 0, and then we have negative 2 and 5. So we have a slope that looks something like this. And then we have plus 2. Oh, I will get proficient at this eventually. So we have our, so it crosses at 2, and then we have the same exact slope. Whoa. So if I drew this correctly, which I didn't, but if I did, we are going to notice that these are parallel lines. So it says to graph it, and then it says, what do you notice? We notice that they are parallel. And what does it mean when you have parallel equations? You have 0 solutions. Okay. Let's see, what else do I need to pull out of here for you guys? So, last thing with this is it asks you what it's called, and this is an inconsistent equation. So, like the chapter it's called inconsistent and equivalent equations. We go back up here. Our parallel lines are going to be our inconsistent equations. And then our lines that are directly on top of each other and have an infinite amount of solutions is going to be our equivalent equations. And that makes sense because they are the same thing. Okay, those are those 2 lessons. Pretty simple. I will post the homework that I expect you to do from those. Lesson 6 we already did. We did that through the worksheet of solving for substitution, so we will end up skipping the book part of that. And then we will go to lesson 7. Okay. And I will make a separate video for lesson 7.